to put on the only royalty-free music I actually own. Bad times. Bad times. Wait, where is it? Royalty-free music. Here we go. It's just an intro, don't worry. Alright, how do I find the stream? Alright, that's enough of it. Alright, hey, how you guys doing? That's the only, as I typed in the chat, that's actually the only royalty-free music that I own. So, yeah, that was my old band. Alright, so today I'm going to be doing some digital stuff. Let's take a look over at the bench. As you may or may not know, I've been playing around with the Analog Discovery 2, which you see there. It's got the BNC adapter board connected on. And I also then attached this on the end here. So this can either plug in to the end of the adapter board where the signals are no longer attached in here, or you could just plug it in directly and just take the BNC adapter board out if you want to actually have, that's what we did before when you had the scope signals and everything else on here. So I'm pretty much going from scratch here. I have not played with the digital stuff at all, but what I do have is a Teensy ready to go with some headers on here, so I can either put it on a breadboard or I can just hook on directly, which I'm guessing is what's probably going to happen. So I'll probably just hook right onto the pins here for things like SPI or whatever. And I'm just going to play around here, probably look at the protocol analyzer, and then probably also look at, you know, whatever other functions there are. Going back to my screen here, if you don't know, Contextual Electronics has a forum. And so if you got any questions or if you have anything you'd like me to talk about on these streams that I'm doing, I'm basically kind of just practicing to see if this is something people enjoy, if this is something, I mean, obviously it's something I need to get better at, as you'll probably see throughout this episode, or this stream rather, when I, well, I pretty much always leave the camera on the wrong thing. So, without further ado, I guess I gotta actually start up. So let's go start up the Analog Discovery software, which is Waveforms. So that's what, oops, he's almost dropped my phone. That's what this looks like. So from here, let's take a look at some of these other functions here. So far we haven't played with the supplies, but we've definitely done WaveGen, we've done scope, we've not done voltmeter, but it's pretty straightforward, I assume. Supplies we've not done, data logger we haven't done, logic pattern, static I/O, network analyzer we haven't done. We are going to do that in the future. Again, that's what we talked about with the RC last night. Was just streaming and playing with the RC with an RC filter. Actually, you can see that on the board here. That's what this was. So just an RC filter we were playing with there. So we'll do a network analysis at some point. And then I assume protocol, yeah, so this is like SPI and I2C. Yeah, here we go. So SPI and I2C, if you want to just specifically pull out the stuff, so we might do this as well. All right, so let's see what we got here. We've got a logic analyzer. Okay, I guess I can make this bigger. So we can do click to add channels. Aha, and so we can also do the protocol analyzer here, but then you have to list the individual signals, which makes sense. So in order to do, well, I don't even want to go that far yet. Let's see what else we can do here. So it looks like we need one wire, I2S, which is audio, CAN, which is for cars, UART, which is another word for serial. Oh, that's not serial, it's signal. Okay. I2C, which is usually used for talking to a bus of sensors. SPI, which is a more direct version to talk to sensors, and it's well, more direct because it has an input and an output, and then a chip select to switch between multiples if you put it on a bus. It's just a different type of bus. This must just be like a generic bus. Yeah, so this is like a parallel bus if you want to do that. And then, what's the signal? Signal, it looks like it's just 1. So I suppose we can do this real simple. So let's go and hook something up here. So if I go to, there we go. So for up close and personal with this thing. So if you don't know, this is a Teensy. This is one of my favorite types of little Arduino compatible thingy-dingies. And so what I'm going to do is I'm going to hook in, let's see, so I can hook in a ground, it looks like. I'm going to hook a black wire here into ground on this board, assuming I can. I don't know these by heart, so we'll have to do some of this stuff on the fly. Cool. All right, so now that basically zero references this thing, and then I'm going to grab, what is it? So looking at this, hopefully you can see this. So it looks like DIO10 or DI rather, DI00, DI02. So it looks like it goes up to DI07. So it looks like 0 through 7 is on the top side. I assume that then on the bottom of this connector, it's a two-tier connector here. On the bottom, so it probably goes 0, 8, 0 on the top, 8 on the bottom, 1 on the top, 9 on the bottom, that kind of thing. At the beginning, I'll just use the easy ones here. All right, so I'm going to grab the far right, which is DI7. Cool. And then let's see if we can't hook this in here. I think if I hook into pin 13, I think that's actually what's flashing that LED on here, right? So this is just the default blink sketch on an Arduino and a Teensy that when it boots up. So let's go back here and see if it's actually pulling this in. It would be a very, very slow thing, so we'll have to set that properly. But let's go back to right screen. Ooh. So my cameras are starting to blip a little bit. Sorry about that. So we got right screen. Let's hit run. And then let's also take this down. So we don't need to go much more than, let's see, probably 100 milliseconds per div. Oh, that's DIO3. Let's get rid of that. Right click, remove. Add channels, we want signal DI07. Hey, look at that. It's like crawling like a caterpillar. And if it, let's see if it actually, cool. Okay, well that's a good start. It doesn't look like it's triggering on anything. Let's see what happens when we do that. Looks like I can name them as well. Oh no, sorry, I was right-clicking? No, how did I do that? It looked like there was a trigger. That's an event. Ah, here we go. Ignore 0, 1. So let's do rise. Well, that's just triggering on the rise. I guess if we try and move out here, I guess I can just scroll. I usually just, so I'm scrolling up. It definitely does not look like it's locking in here. I'm kind of treating this like a scope, and it's not really meant to be treated like a scope, right? Normally you would trigger. Oh wait, so I can trigger on patterns, event, rise, reset, none. I would assume that if I trigger on a rising edge, that the rising edge would happen like right here, but it does not appear to be doing that. Okay. Yeah, it's like a little bit off. But maybe I'm just going too slow. Yeah. Okay, well, that's something. Let's go over and look at the comments. Hi, Jeff. Hi, Sebastian. Jeff says the analog discovery looks a little large. So just switching back to that real quick. So ARM. Just as a reference, well, what's a good reference point? I guess here's a cell phone. Well, it literally just buzzed in my hand. That was weird. One of you call me. Okay, so that's just, you know, it's a decent sized cell phone here. I guess here's a common reference point for a lot of people. If not, you should definitely get a copy. Yeah, so it's not huge. I mean, this is a smaller breadboard too, so something to note. All right, well, let's see what else we can do here. So I guess what I would need to do is go back. Let's go and find a teensy manual here. I'm just going to open up the Arduino. I think I've got the teensy stuff installed. Oops. That's Audacity. There's not still music playing, is there? That's weird. Looks like it's showing music playing, or some kind of audio. Anyone hearing odd sounds? If there is, I'm sorry. Anywho, let's see. Teensy. Pinout. SPI. Cool. So we'll definitely open that. And what I really want to see is just what's the default SPI port. I haven't used this in a while. So it looks like, so pin 12, so it looks like you see how this is darker. Well, that was not helpful. Sorry. View image. Okay. So you see how this is darker. That shows that that's the default, right? So pin 10 is the default chip select. Pin 11 is default data output. Pin 12 is data input. And then pin 13 is S-clock. So those are all good things to know. Cool. Did I open? I don't think I actually opened Arduino here. Let's just do a little sanity check. Let's see. I will do this. How will I do this? Let's just go back over to the right screen for now. Well, no, we'll need to. So if I split my screen here. There we go. That looks all right. Open. Let's go back to the middle screen. This is an older sketch I was doing. Examples, Teensy, tutorial, blink. There we go. Okay, cool. So I'm just gonna sanity check this, and if you'll excuse me for a second, I need to just update my thing here. Just gonna put this on here so that you have something on screen, but then I have to flip it around. There we go. All right, sorry about that. Okay, so now we can see the blink in the lower bottom corner, and like everybody does, let's just speed this up. Oh, number lock isn't on. There we go. And let's upload it. Compiling sketch. Let's see if it finds it. Doesn't look like it is. There it is. All right. So it didn't show it, but little teensy guy was here and did upload it. And is it going faster? Yeah. And so it is going faster now. Cool. So we're able, there's our nice sanity check. We're able to connect to the board here. Let's see what else we got in the old example bin. I think we should have probably a SPI output, and that would be great for us, right? Okay, Teensy. Crud. I was hoping there would be, but I guess not. What else we got in the example side of things here? Analog, digital. Guess I'm gonna have to go and do this stuff, huh? I have a couple of libraries here. All right, there we go. Let's try this one. This is going to be Hacketry of the highest order. All right, let's see if this just compiles to start with. I have no idea what this is. I mean, Digital Pod. I think I've used this in the past. Oh yeah, 805206. I've used something like this in the past. Let's see. Is it still blinking? No, it's done blinking. So that's probably a good sign. Oh, look at that. And so if we go here, right screen, we can see it's scanning. So that same 13. So this is actually the chip select. That's what we're seeing now. So I'm going the wrong way. Let's set our position to 0. I'm just trying to get in here and see this thing. Yeah. Oh, is this a chip? No, sorry, this is the clock. Sorry, pin 13 is the clock. That's right. Okay, cool. So let's hook in some other stuff here now. All right, so if we go back to where? Middle screen. While I do that, let's also see what y'all are saying. Anything? What did Sebastian say? Can I pop out the chat? I keep forgetting how to do this. Sorry. Pop out the chat. There we go. All right. So I can also put that here. Let's see. Can you do protocol-specific packet interpretations like in one of the fancy scopes? Yeah, that's what I'm about to show here, actually. So I'm about to show SPI right now. So Now that I've got this all set to go. Hello, Amperature. Okay, so we've got the S clock is hooked up on pin 6, or sorry, pin 13. So I think I can go and rename it here, like that. Yep. And then I want to add, no, crud. I'm kind of splitting screens here now. Yeah, let's see if we can do this. There we go. Fixed it. Okay, so I almost want to add signal. Oh, wait, I want to add a whole bus. Yeah. I want to add a whole bus now. Okay. Let's add a bus. So we've got pin. The select pin is going to be pin. We have to actually name that, huh? Yeah, we can probably just match 10, 11, 12, 13, huh? Yeah, let's just do that. Okay, so I'll just unplug 7. That should stop. And then let's go and grab. So this is 15, 14. This is kind of a mess. But to be fair, it's a mess for any logic analyzer, really, in my experience. Okay, so 15, 14, 13 is green. So we're going to hook 13 into 13. Hook 13 into 13. Cool. Then let's go. And you know what I'm going to do is I'm going to actually pull the BNC thing off here. This is just really bulky for no good reason. It is interesting. This is kind of heating up. I wouldn't have expected that. All right, there we go. I mean, this I expect to heat up, right? This is running, it's got a power supply and it's running FPGA in there and stuff like that, but wouldn't have expected the BNC board to heat up. All right, let's pull this back off of here. All right, so we got 4. Then what I'm just doing here is I'm just counting, so I know that it's 0 referenced. So I'm going to say this one is 15, right? And then 2 down would be 13. 11 is pink. I'm sure I could pull these colors out of the manual too, but on the bottom side wires, they're basically the same as the top side wires, right? So if pin 0, already said pin 0 is above pin 8, but if pin 0 is a brown wire, then pin 8 would be a brown wire with a white stripe. So that's how this is done. Okay, so pin 13 hooks onto here. Pin 12. Nope, that was backwards. Pin 12. And then brown is pin 11. And then, sorry, brown is pin 11? Yep. Got that backwards already. And then purple is pin 10. Cool. And really, I mean, like, 0.1 inch headers or 2.54 headers for our metric friends. They never go out of style here. They are actually still really, really convenient. All right, so you don't really need to see much more than that. There's the, so now we're hooked on here. So hopefully, now that I do this, if I go back here, so I want to do pin select. So now you can just follow along. Select is 10. That looked good. There's something coming through there. Clock is 13. Data is add SPI. Huh. I guess if this is receiving, so it would be the data output, right? So if we want to look on the analyzer at data, it has to be coming out of the teensy and into the thing, so it would be 11. Okay. And we'll say, it looks like pin 7 up here is just doing noise, but format decimal. Crud. I saw something there. Oh, we might be... Okay, so let's trigger on chip select, which is pin 10 now. Advanced. So we don't want to trigger on 7, that's for sure. There we go. Look at that. Isn't that pretty? Oh, okay. So this actually makes it really easy to tell what we're... So let me just get rid of this guy. So this makes it easy to tell exactly what's happening now too. This is actually probably a pretty good example for our stuff here. Hopefully you can see this. Looks like the wires are a little bit low, but or thin rather. The drawing on the diagram here. But yeah, so when you set up a protocol analyzer like this, so this is a SPI protocol, right? So it's reading the data line, it's syncing up with the clock. We have the chip select low to actually say that that's when it's active, right? So if we zoom out here, you see there's a whole bunch of time in between where it goes idle, right? But then finally when the chip select goes low, you know it's time to do it. And obviously what this thing's doing is it's just going through, so it's a 2-byte word, right? And it's just going 0 up to 255 and back down, then it'll go to 1, up to 255 and back down, and it'll go to 2, yada, 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 right? So it's really just syncing through this stuff. Now, chip select might also work where you might have a separate chip on board where the SPI bus is working on what am I trying to say here? You might have a separate chip on board where you're talking to one or the other, and the chip select on the first one goes low, and that means that chip selected, and then the other one goes low, and that chip selected. That's where the name comes from, of course. So that was a stupid explanation, but this actually looks pretty good. So I'm not sure about the limits of what it takes to, or how fast this thing can go, but most SPI buses are, in the megahertz. They're not they're not going super fast. You can go faster, but it's usually pretty advanced. At that point you're going to have to go to something a little bit crazier anyways. Okay, cool. I guess I could do the same thing for I2C. I'm not sure I will. But it's nice that that the inputs are selectable as well, right? So and I think even though we're doing this, we can still measure analog. I wonder how we could do that. It's too bad we don't actually have this chip on board, or on hand rather, because then we could have measured this and then measured the resistance going through because it's a digital potentiometer, right? That would have been cool. Okay, well this is cool. I'm not sure why this is separate. Right. I wonder, yeah, and I did actually wonder about this. So one thing I was wondering about with the Discovery, Analog Discovery 2, was whether I could actually output something, right? So almost like peek and poke for a SPI part, right? So that's actually something that's really, that's what I do normally with Teensy or just an Arduino in the first place. So if I just want to hit the register and follow the datasheet diagram, you saw that in the first version of Contextual Electronics when we were just talking to the ADC. We were really just kind of trying to figure out, okay, well, we throw this set of bits at this register and it sets it sets like the speed and it does all this, and we were doing bit masking and all that crazy stuff. And that's really, anything you're doing when you're interfacing to sensors or interfacing to ADCs and stuff like that. So it is definitely a good thing to be able to do without having to have, a full setup, right? So you don't have to have, a micro on board to always talk to the sensor. Sometimes you just want to talk to a sensor breakout, right? So, and you can do that with a lot of platforms. It's just nice if you can do it while you're also testing other things. So I'm not sure if that's actually what we're looking at here. So if we just do right, that's interesting. Oh, look at that. Scripting too. I know that there is scripting on the Analog Discovery. There's like Python scripting, I think. Or just JavaScript. This looks like Java. Well, function. Anyone know what this is? Andrew asks, what kind of sorted devices are available with the SPI interface? It's a good question. There's some sensors. Sensors are not, there's no hard and fast rule, but a lot of the sensors I've seen these days are doing more I2C type stuff because you might want to hang a couple of them off the same bus with fewer lines. Like I said, in the first version of Contextual Electronics, we had the what was it, the MC3902, but it was a 2-channel ADC that we were using, and that was a cool little part. So there was an ADC, and then we also had a DAC on board that was also SPI based, and so we just used the chip select to go between the two, because usually we were reading the ADC a lot more than we were writing to the DAC, so it worked out fine. Usually it's just when you're doing lots of updates on something, that's when it starts to get kind of troublesome. You might want to have, instead of having a shared bus, using the chip select pins between two devices, you might actually want to have two SPI inputs, because there is just some bus contention. It will slow you down. But yeah, there's also some sensors. There's other controllable stuff. There's a lot of those. If you've seen those like 16:8 screens that you can get, like kind of just the simple dot matrix display type screens. A lot of those are SPI based. So you're just talking to one of the control chips on board, and you're saying, output this pixel, whatever. So I don't really use those very often. Andrew also asked, is SPI single-ended or differential? It is single-ended. So there is multiple pins involved. What you'll usually see is if you say MISO or MOSI, that's usually what you'll see there. So there's usually chip select, there's a clock, and then MISO is master in, slave out, right? So that's really, it's said like that in order to say who's output and who's input, right? Because if you just said data, like so like we show here, right? This shows data output, right? But that means that this device, this teensy, can act either as a master or slave, right? So if I was writing, so say I figured out how to get this protocol thing working, right? And I wanted to write to the teensy, then in that case, this D out would be a MISO pin, right? Because it would be slave output. So that would be the line that would connect up to here. If this became the master, then this would be the MOSI pin, because then it's master output. So it's a little bit confusing, but okay, so that wasn't Python, like Sebastian said. Yeah, I'm not sure what this scripting language is with. It says it has a little JavaScript notation down here, so I assume that's what it is, but maybe not. Anyways, that doesn't really matter. I'm not going to do scripting. But I lost my train of thought. So anyways, yeah, so single-ended, but then there's MOSI and MISO. You have to determine who's talking to who's doing what, right? So if this teensy was talking to a sensor, right, then this would be, so pin 11 would be MOSI. Right, that's what you'd hook up to here, right? Because it'd be master out, slave in. You're sending data out of the teensy over to the sensor, and the sensor has data input there, right? So, yep. Master out, slave in, master in, slave out. That's right. That's what Emmanuel said. Right. So MOSI, MISO. Cool. Yeah. So there's tons of stuff online about that stuff, and we do it in the course as well, so you can definitely check out that. I feel like I need to try this, though. Yeah, why not? Let's just do a little loop back, right? So I'll just hook in. So I'm just going to, what am I going to do? I can just do... Yeah, okay. We can do this. All right, so I'm going to unhook this stuff. And I'm going to say, let's just keep using the same lines here. So I'm going to say pin. Good. Okay, so pins 14 and 15 are going to be, so we're going to say pin 15 is clock, and pin 13, you know what, let's just make it easy. Pin 14 and 15 are both clock. Pin 12 and 13 are both data. Right, so we're going to do I squared C now. I'm just really, like, literally hooking these together. Or trying to. Okay. Let's do that. So what I need to do, I think, is, so let's see, I said 14, 15 were clock. So we'll say 15 here is clock. And then this will be 13 will be data. Okay. And then I think I'm going to try and break this guy out of here. So you can break him out. So what I'm going to do is just get rid of this bus, add a new bus, I squared C. So I'm going to say clock, so 15 was clock here. I'm going to say 14 is clock here. And then data, I'm going to say that's 12. And then I'm going to trigger on the rising edge here. Okay. Verify signal pull-ups right, of course. So I might need to go into a board first. You do need pull-ups on here. Okay. Well, we can do this too. So we'll just go right, because this I squared C line, right, all it cares about is, so it's going to tug on the line low. All right, so hook this in like this, and this in like this, and now what I'm doing is basically just hooking both of these into the same node. Okay, not sure if you can see that. So basically, both the datas are now hooked into the same node. I'm going to do the same thing for the clocks. I'm hoping this is going to work. And then what I'll do is I will just I'll do a pull up here with the 5-volt rail. This is usually where I stop being such a fan of these kind of systems. Okay, so we got the V here, so I'll put on this rail. Okay, and we're going to try this, and if it doesn't work, I'm probably just going to give up on it. Okay. Verify signal pull-ups. Crud. So what I would have expected to see is something here. So we got SCL and SDA. Let's see if there's actually voltage on here. That could be possible. I may not have turned on the voltage output, so that could be problematic. Sorry, you can't see what I'm doing here. Let's do this. Yep, no voltage. Okay. Yeah. So then if we go and turn on the voltage, welcome, supplies, I guess we're going to see this. So we'll turn this up to 3.3. I assume that'll be acceptable here. Master enable is off. We don't need the negative supply on. Oh, there we go. Okay, now let's try that again. I know you can't see what I'm doing with the DMM, but just trust me on this one. Not worth the setup. Alright, we got some voltage now. Looks like it's only 3 volts. It's weird. I set to 3? Huh. Well, not really sure, but there is some voltage now, so let's see if that matters at all. Right? Hey. Okay, well, it's not getting any ACK back. Yeah. Well, let's see it now. So Andreas said that as well. So there's not going to be an acknowledge, but no, it just wasn't writing before. I mean, we could do a read as well, right? I mean, I guess it's the same thing. But I think it might be that it doesn't like, let's see. Yeah, maybe it is that. I still think it would be like, so we're showing high now, so that's good. I guess we care about the falling edge, not the rising edge, but not that it really matters. Let's set this back to 0. Microseconds per div. We're going a little too. Yeah, I agree. I should see something on it. Yeah, you're right. I should see something. I think it might just be the read back here. Let's see if I've got the right pins and everything. All right, so I've got. Oop, what did I do? UV blog meter is about to blow up. Well, that looks right. 14 and 15 are talking to each other. Yep. 14, 15, 12, 13. That stuff all looks right. It's probably just I've got something messed up here. But needless to say, it does look like I'm capable of doing writing here. I don't actually have. What do I have? Any sensor boards? Now this is an Adafruit thermocouple board that I have, but this is actually SPI. Looks like it's got CS, DO, and CLK. So that looks like it's just a single output thingy. What else do I have here? Yeah. Well, I'm going to leave that for another night. I'm starting to get a little warm here anyways. I'm in my increasingly sweltering part of my apartment. But I think overall this has been pretty positive. So I still need to check out this custom scripting type thing and play with this a little bit more. Probably go and just see if there's other people I'm sure there's other people on YouTube that are doing this kind of thing as well, where they just, they write scripts and stuff like that. So I would actually like to see this stuff in action. Andrew asks, is SPI a more simple protocol than I2C? Depends on your perspective. I think so, but I always started with a SPI, so a little bit simpler for me. I think it's just a little bit more straightforward because you're not pulling stuff down. You're actually actively driving and listening to signals instead of just like waiting on a bus. I2C, you have to actually like tug on the line, and that's why you need pull-up resistors. Anywho, okay, well, another successful-ish stream here. Thanks to everyone who stopped by. I'm not sure how many people are hanging out, but it's always really nice that people come and hang out with me while I'm in my lab and really, literally just messing around here. I don't actually know most of what I'm doing here. So looks like 10 people are here, so that's cool. Yeah, so I'll be back tomorrow. I'm trying to get a weekend of these in. So if you've got anything you'd like to see, like I said, head over to forum.contextualelectronics.com. I'd love to, point out if you, so like Andrew's asking about SPI and I2C and stuff like that. If you've got stuff you'd like me to cover specifically, would love to try it. I have no guarantees. And I am going to get back. I'm going to try more of this, more of the functions here. So like doing things like the network analyzer. Overall, I'm actually really pleased with how this stuff's been going. If you didn't see, just to go back to here again. So you got the supplies. I guess it's opening these, but so it's got all the voltmeter, logger, logic, patterns, whatever. So great little tool for people that are getting started and building out their labs. We don't do much with breadboards. If I'm being honest, we don't do much with breadboards in contextual electronics because I don't like keeping the parts around. I don't think it's actually, it's good for basic stuff, and that's what I'm doing here. But, if we build real electronics, so, things like this. We're building real electronics, but we still need to test them. So, things like this, we can go and pop onto the CE header if we need to, stuff like that. So we'll talk more about that in the future, I'm sure. If you have any questions, you can always leave them below, but definitely better is to go over to the Contextual Electronics Forum. And yeah, thanks for watching. I'll play out with that same music. Sorry about my band's old playing. See ya.
Thank you.